Screen is visible to you?
Yes, ma'am, it is.
Fine. So today we are going to learn about the chemical bonding and the molecular structure. This would be our third chapter. Okay, which I'm going to start. So what do you mean by the chemical bond, first of all? So see, these are the few notes which I have sorted from the internet, which are quite important as well. If you go through your textbook, textual content is too much. Actually, obviously, NCERT textbook is really good, but then you have to invest a lot of time to read it, isn't it? Because
Yes,
of
ma'am.
that, I have sorted few things from the internet, and that I'm going to share with you. So, what is the chemical bond? The force that hold a different atoms in a molecule is called as a chemical bond. So that chemical bond can be ionic bond,
Covalent
that
bond.
can be covalent bond, right? These type of bonds you have already learned in your grade 10, correct?
Yes, ma'am.
Yes or no? An ionic bond is also called as what? Electrovalent bond,
Yeah, yes, ma'am.
right? So octet rule also you're aware, I guess, right?
Yes, ma'am.
What
Yes, ma'am.
is atom of a different element take part into the chemical combination in order to complete their octet or to attain the noble gas configuration, right? This is
Yes,
called
ma'am.
the octet rule. And with respect to hydrogen and helium, it is exception. These two elements try to complete its duplet.
Yeah, yes, ma'am. They complete their duplet.
Duplets. It won't go for the octet because it has only one shell, and that shell is what? K shell.
Yes,
Correct?
ma'am. And it can
Right.
only fill 2 electrons.
Yeah, it can only fill 2 electrons in it. Now, next, valence electron. This is also one of the important term. So, number of electron or the electron present into the outermost shell of an
Outermost
atom
shell.
is called as what? Valence electron. Correct?
Yes, ma'am.
It is the outermost shell electron which take part into the chemical combination. This is called as what? Valence electron. Now, one of the important thing you have to learn in this chapter, that is causal in the relation to the chemical bonding. What his contribution? What facts he has stated that we have to see in this chapter. Causal in relation to the chemical bonding. What he said about it, that we are going to see thoroughly in this chapter. So the first point which it has been said by him, that is, in a periodic table, the highly electronegative halogen and highly electropositive alkali metals are separated by the noble gases. Correct?
Yes, ma'am.
Yes or no? What he said, causal in a relation of chemical bonding. He said in a periodic table, the highly electronegative halogens and highly electropositive alkali metals are separated by noble gases. Then the second thing which has been stated by him, that is formation of an anion and cation by halogen and alkali metal are formed by gain of electron and loss of electron respectively. This is also true, correct?
Yes,
And both the negative and positive ions acquire the noble gas configuration. Yes? Yes.
yes, ma'am.
By completing the octet into the outermost shell. The negative and the positive ion are stabilized by electrostatic attraction. How
Electrostatic
negative and
force.
positive charges are stabilized? By the electrostatic attraction. For example, they have given here one example of sodium and chlorine. You'll come to know.
Yeah, yeah, yes, ma'am.
Yeah. Sodium, when it's lose its one electron, it will convert into what? Na plus 1, or only Na plus you can write by losing one electron, correct? Yes or no?
Yes, ma'am.
Yeah. So if you see the electronic configuration for sodium, it has a neon configuration and 3s orbit have a 1 electron inside it. Neon has a 10 electron and 1 extra electron goes to the 3s orbital. Correct?
Right,
Yes
ma'am.
or no?
Yes, ma'am.
And one this electron has been gone, your configuration would become exactly like the inert gas. isn't it? With 10
Yes,
electrons.
ma'am. They attain the noble gas configuration.
Yes. So Na plus or positive ion shows what? What positive ion shows us? Inert gas configuration, isn't it?
Yes,
Yeah.
ma'am.
Okay. Now see the next Na plus, sorry, Cl minus. If you see here, I'll write it here for your understanding. Let me clear the annotation. Actually, I need it. Fine. Cl, when gain one electron, right, with negative charge, it will convert into Cl minus ion, isn't it? So if you see about the Cl, you have an electronic configuration like what? Ne, right? 3s2, 3p,
Three.
right? And by gaining one electron in a p orbital, it will be convert into Ne, right? 3s2, 3p6, correct? Means your p orbital is completely filled. And if you count this, these are the 10 electron for the neon, then 12, 12 and 6, 18. So 18 electrons will be present into argon, correct? So it is equivalent to the argon gas configuration, which is a noble gas. So in both the cases, sodium by losing the electron, it convert into neon, inert gas configuration. Chlorine by gaining electron convert into argon by gaining the electron, right?
Yes, ma'am.
Sodium by giving electron convert into noble gas, and chlorine by gaining electron convert into noble gas. And they develop a separate charge on each, that is Na plus and Cl minus.
Cl
And
minus.
these oppositely charged ions has a force of attraction in between them, and they form a stable compound, that is NaCl. Correct?
Yes, ma'am.
Which force of attraction is there in that? Electrostatic
Electrostatic force.
attraction, isn't it?
Yes, ma'am.
Electrostatic force of attraction in between of oppositely charged ions. Clear? So these things we have to keep it in your mind regarding what? Your causal in relation to the chemical bonding. What I said about the causal in relation with the chemical bonding. First of all, in a periodic table, he said highly electronegative halogens and highly electropositive alkali metals are separated by noble gases. Then formation of anion and cation of halogen and alkali respectively happen by gain of electron and loss of electron. And both negative and positive ions can acquire a noble gas configuration. Just now we have seen sodium positive ion, chlorine negative ion. And these negative and positive ions are stabilized by the electrostatic force of attraction. An example is given to you in front of. Now we are going to see about the modes of chemical combination. Fine. Good afternoon, Dhananjay. Now we are going to see about what? Modes of chemical combination. Now see here, in modes of chemical combination, what is given to you? By the transfer of electron, the chemical bond, which formed by the complete transfer of one or more electron, form an atom to the another, is termed as electrovalent bond or ionic bond. Isn't it? See, by transfer of electron, the chemical bond which is formed by the complete transfer of one or more electron from one atom to another, termed as electrovalent bond or ionic bond. And the bond which is formed by the equally sharing of electron between one or two atoms is called as what? Covalent bond. Right? These bonds are electron or these bonds, electrons are contributed by both in the covalent bond, right? In this first case, electrovalent bond, what happened? One element would be give electron, another would be take electron. So this kind of bond is what? Give and take relation, right? Is there in this? This
Yes,
is
ma'am.
called as what? Electrovalent. And in covalent bond, what? There would be the equally sharing of electron. One electron would come from A, one electron would come from B, and both the atoms share the pair of electron. And such a bond is called as what? Covalent bond. Fine. Such a bond is called as what? Covalent bond. Okay. So there are the two mode of chemical combination. One by the transfer of electron and second by the sharing of electron. When electron has been transferred from one atom to another atom, that is called as what? Electrovalent bond or ionic bond. And when there are the electrons are equally shared by both the atoms in a chemical bond, that is called as covalent bond. One more type of bond is there, that is a coordinate bond. See here it is given. So what is the basic difference in between the normal bonding and the coordinate bonding? When the electrons are contributed by one atom and shared by both, the bond is formed and is known as a dative bond or coordinate bond. So this name you need to keep it in your mind, dative bond or coordinate bond. Dative bond is another name for the coordinate bond. Means what? A may have a pair of electron extra, B does not have. A is share its pair of electron towards B and form a bond. Right? But then in this case, it's not an equally shared bond. Only A has a sharing capacity. So it shared the electrons with B and B just accept it. Okay. And such a kind of bonding is called as what? Coordinate bond. What?
Is that what happens in a hydrogen and chlorine bond, ma'am?
No,
Hydrochloric
no, no,
acid?
no, no, no. It doesn't happen into the hydrogen and chlorine bond. It happen into the generally complexes. The
Okay.
inorganic complexes which are formed, that mostly formed due to the coordinate bond. Understand? In that case,
Yes,
what
ma'am.
when ligands are there, different ligands, those ligands donate the electrons towards the metal, because we know metals are electropositive in nature, right?
Yes.
It cannot share the electrons. They are electron deficient, and in that case, only ligand would be share the electrons, but then bond is like a covalent bond, but then actually it's a coordinate bond due to sharing of electron only by the one side. Understood? Clear? Yeah.
Yeah, yeah, yes, ma'am.
In this case, first case, what happened? Where my cursor went. Okay. Lost. Let me connect it up properly.
So in coordinate bond, ma'am, only one atom shares its electrons to the
Yeah.
other atom.
Yeah. In this case, what happens? See, mode of chemical bonding is by transfer of which one this? By transfer of electron, electrovalent bond. In that case, A and B. In that, A would be given, B would be taken, right?
Yeah,
So
yes, ma'am.
that is a electrovalent bond, and we called it as a ionic bond, correct?
But in this coordinate bond, A gives the electron, but it
Pair of
also shares
electron,
with it.
pair of electron.
Yeah, yeah,
It
yes,
won't be
ma'am.
single electron. There would be the pair of electron. Understanding?
Yeah, yeah, yes, ma'am.
Clear? Yeah? Fine.
Yes, ma'am.
Okay. Now see, in a covalent bond, both will be equally shared, and in coordinate bond, only one would be shared and second would be just accept. It wouldn't be shared, and hence it is coordinate bond. I hope understood by all the three bonds. Dhananjay, have you understood three bonds, all three bonds clearly? Yeah? Fine. Now we'll move forward, ionic or electrovalent bond. We are going to learn about the ionic bond or the electrovalent bond. In this case, what is given to you? See, ionic or electrovalent bond is formed by the complete transfer of electron from one atom to another. Generally, it is formed between the metals and non-metals, right? We can say it is electrostatic force of attraction which hold the oppositely charged ions together, right? And the compound which is formed by the ionic or the electrovalent bond are known as electrovalent compound or ionic compound. Example they have given for the NaCl, correct? NaCl is an electrovalent compound. Formation of NaCl is given below. In that case, what we come to know, see, sodium has electronic configuration 281, whereas chlorine has electronic configuration 287. In this case, they have just shown the outermost shell or outermost electron over here. You can see only one dot with respect to one electron present in the outermost shell. Are you able to see only one dot here?
Yeah, yes, ma'am.
Yeah. And here you can see 1, 2, 3, 4, 5, 6, and 7 electron with respect to the outermost shell or valence electron present into the chlorine. That has been shown. So to complete octet for the sodium, sodium supposed to like give this one electron. Outermost electron should be donated. Okay, so it donates one electron, and to complete octet to the chlorine, what it should gain one electron. So sodium would give one electron, and chlorine will gain one electron from the sodium, and both they complete their octet. You can see this is a neon-like configuration, and this is argon-like configuration. Both will show the noble gas configuration by completing its octet. As its losses electron, positive charge would be appear on the head, and as its gain one electron, negative charge would be appear on the head. And there would be electrostatic force of attraction in between oppositely charged ion, and hence this bond would be electrovalent bond. Correct? Yeah. And the compound which
Yes,
we
ma'am.
give NaCl, that would be electrovalent compound. Right? Like this number of electrovalent compound we are able to form, right? Yes or no? Formation of magnesium oxide from the magnesium and oxygen in the same way it would be takes place. Okay, fine. Can you frame? Can you frame the reaction? What will be happen with respect to that? Yeah.
Yes, ma'am.
Please go for it now. Here. Yeah. Now you can check, student, here. Magnesium, its atomic number would be what? 12, and its electronic configuration 282. Correct? And with oxygen, it's going to react. Oxygen, its atomic configuration, its atomic number is 8, and its electronic configuration would be 2, 6. So if I have to show the outermost electrons, here magnesium has a 2 electrons and oxygen has a 6. Means 1, 2, 3, 4, 5, 6. So to complete octet by the oxygen, it required 2 electrons, and 2 extra electrons are present in the magnesium. So magnesium will donate these 2 electrons, correct? And it will go to the oxygen. By donating 2 electron, magnesium become Mg 2 plus, right? And by gaining 2 electron, oxygen will become O minus 2, isn't it? With all the 8 electrons in the outermost shell, correct? Yes or no? And when there would be the electrostatic force of attraction in between these two, it will form a bond, that is the electrovalent bond, right? So you get Mg plus 2 oxygen minus 2, correct? Magnesium oxide compound. This will be what? MgO. Clear?
Yes, ma'am. Yes.
Yeah. So this already you have learned in your grade 10th, I guess. It won't be too difficult to understand by you. Fine. Now see next. Electrovalency means what? Electrovalency is a number of electrons lost or gained during the formation of ionic bond or electrovalent bond. So what is the electrovalency for magnesium? Plus 2. What is the electrovalency for the oxygen? Minus 2. Electrovalency for the sodium would be plus 1. And electrovalency for the chlorine would be minus 1.
Minus.
Understanding? What is electrovalency? Number of electron lost or gained during the formation of an ionic bond or electrovalent bond. Clear?
Yes, ma'am.
Fine. Now we will move forward. What are the factors which are affecting on the formation of ionic bonds that we are going to see? Yeah. Here are the factors which are affecting onto the ionic bond or the formation of ionic bond. See, first of all, ionization enthalpy, the first term which affect on the formation of ionic bond, that is the ionization enthalpy. Already we have learned about the ionization enthalpy, right? In the last chapter, what it was? About ionization enthalpy, I have explained in a periodic properties or not?
Yes, ma'am. It is the amount of energy required to remove the electron
One
from the
electron
outermost
from the
shell.
outermost shell of an
Yes, ma'am.
isolated gaseous atom to convert it into its cation, correct?
Yes,
Yes
yes,
or
ma'am.
no? Fine. So same thing would be given over here. As we know that ionization enthalpy of any element is amount of energy required to remove an electron from outermost shell of an isolated gaseous atom to convert it into its cation. This is actually definition for the ionization enthalpy, right? Hence, lesser the ionization enthalpy, easier will be the formation of cation, correct? And hence have a greater chance to form a ionic bond. Due to this reason, alkali metals have more tendency to form a ionic bond. Why alkali metals form ionic bond? Because it has a less ionization enthalpy. If you see the alkali metal, where are the alkali metal? First group, right? Yes or no? What are the alkali metals? First group, like see hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, etc.
Francium.
Right?
Yeah,
These all
yes, ma'am.
have one electron in their outermost shell. All the atom have one electron in their outermost shell. If you see 1, 3, 11, right? It would be 2, 8, 1. So again, one electron into the outermost shell.
Yes,
Potassium
ma'am.
2, 8, 8, 1. Again, one electron in the outermost shell. Right? As it has a one electron in its outermost shell, by giving this one electron, it may acquire a stable inert gas configuration. Right? Yeah. Inert gas configuration means what? Noble gas configuration, right? And hence its ionization enthalpy is less. And as its ionization enthalpy is less, it can easily remove one electron from its outermost shell and can easily form a cation. And hence mostly alkali metals undergo to the formation of ionic bond. Example they have given for the sodium. Sodium ion has ionization enthalpy just 496 kilojoule per mole. Okay, next. While
Yes.
in case of magnesium, it is 743 kilojoule per mole. Why it is 743 kilojoule per mole? Because in the magnesium, there would be two electrons instead of one in the outermost shell. Keep it in your mind, right? So instead of, means like removing one electron will not be complete its octet. Understanding, and hence its ionization enthalpy is more as compared to sodium. Clear? Yes? Students, I need your response. Unless and until
Yeah,
you,
yes, ma'am.
yeah, sodium, what I said about 2, 8, 1 electronic configuration. For magnesium, it will be 2, 8, 2. So if you remove one electron from each, it will complete its octet, right? But then here octet wouldn't be complete. And hence, to complete its octet, one more electron need to be loose, right? And hence its ionization enthalpy is more as compared to sodium. Right, magnesium has more ionization enthalpy as compared to sodium. Okay, fine. Therefore, we conclude
Yes.
that lower the ionization enthalpy, greater are the chances to form a ionic bond. Okay, now next, electron gain enthalpy. Now, how electron gain enthalpy is affect on the formation of ionic bond. What is the electron gain enthalpy? This is also we have learned into your previous chapter, isn't it? Yeah. What we
Yes,
have
ma'am.
done about it, electron gain enthalpy. It is defined as energy released when isolated gaseous atom take up an electron from to form an anion, right? For example, Cl, when it accepts one electron, it will form its anion Cl minus 1, correct? Yes or no? So how much amount of energy would be released by this atom by gaining one electron and convert into anion? Okay. So that is called as what? Electron gain enthalpy. It is completely opposite to your ionization enthalpy. Correct?
Yes, ma'am.
Yeah. So what is given here? Greater the negative electron gain enthalpy, easier will be the formation of anion. What is given? Greater the negative electron gain enthalpy, easier will be formation of anion. Consequently, probably a formation of ionic bond increases, right? If greater negative electron gain enthalpy, then formation of anion become easier. When formation of anion become easier, chances of formation of ionic bond is also increases. For example, halogen possesses high electron affinity, so that formation of anion is very common in the halogens. And hence, almost all halogens are formed ionic bond. Understanding? So which are the factors affecting onto the formation of ionic bond? First of all, ionization enthalpy, correct? Yeah. And second, electron gain enthalpy. Clear?
Yes, ma'am.
Yeah. I hope all of you have understood properly. Jaswant, where were you? What is the time? Yeah. Where were you? Jaswant is not serious about classes at all. See, and the third factor which is affect on that would be given as what? Check lattice energy. See here. Lattice energy or the enthalpy. What do you mean by this? It is defined as the amount of energy required to separate 1 mole of ionic compound into separate oppositely charged ions. Understanding what is the lattice energy? Suppose A plus, right, plus B minus. It has formed the compound AB due to electrostatic force of attraction, and it must be formed by electrovalent bond, right, or ionic bond. So lattice energy or enthalpy is equal to what? It is defined as amount of energy required to separate 1 mole of ionic compound into separate oppositely charged ions. Means how much energy I would require to separate these A and B into their respective ions from their 1 mole molecule. Understanding? Or 1 mole ionic compound. Understanding? So the energy which is required is called as lattice energy or lattice enthalpy. Clear? Hello? Understood?
Yes, ma'am.
Yeah, amount of energy required to separate what? 1 mole of ionic compound into oppositely charged ion is called as lattice energy or lattice enthalpy. Correct? Lattice
Yes, ma'am.
energy of an ionic compound depends upon the factors, different factors. Among that, first one, size of the ion, and second one is the charge on the ions. So how size of the ions affect on it? Smaller is the size, greater will be the lattice energy, right? If
Inversely
yeah,
proportional.
size of the ion is small, that time it is very difficult to separate them, right? And hence we require more energy, and hence greater will be the lattice energy. What respect to the charge? Okay, greater the magnitude of charge, greater the interionic interaction, and hence higher is the lattice energy. If more charge would be there, here instead of +1, if suppose there would be +2, +3, or +4, +7, these kind of atoms are also present, right? Chromium, you know that chromium, then the potassium, it has a maximum oxidation states as well. So whenever there would be a maximum charges present onto the ion, any ion, cation or the anion, it is very difficult to separate. It requires a lot of energy, right? Magnitude of charge is more, and hence your lattice energy is also increases in that case. First of all, size of the ion, smaller would be the size, greater will be the lattice energy. And if greater is the magnitude of charge, greater is interionic interaction, and hence higher would be the lattice energy. So these things you need to keep it in your mind. Fine. Okay. Now we will move forward. General characteristics of ionic compound. What are the characteristics of ionic compound? See. Wait a minute. Yeah. Oh my God. Here it is. Check it here now. General characteristics of ionic compound. Physical state. Generally, it exists into the crystalline solid. Crystalline solid means what, students? Have you ever pinched the salt in your hand? Pinch of salt have you hold in your hand? Ever?
Yeah.
Yeah. Uh, do one thing. Whenever you will be take the pinch of salt in your fingers, you just scrub it. What you will feel? You may get a
They are small
crystals, right?
crystal. Yeah.
Yeah, you may feel crystals. Why those crystals would be present for the salt? And if you take a talcum powder in a pinch, then do you feel same crystals?
No, we don't.
No. Why it is so? Talcum powder is amorphous in nature, and your sodium chloride is crystalline in nature,
Crystalline nature.
right? Why it is crystalline solid? Why it is crystalline solid? Because it's each and every unit, each and every sodium chloride molecule have a specific geometry, specific shape. Okay. Whereas in amorphous solids, there won't be regular shape or regular geometry. But then in case of crystalline solid, each and every molecule has a specific shape. Okay. And hence it is crystalline in nature. Okay. Known as a
Yes,
crystal
ma'am.
lattice. Fine. So what about the physical state is given for the ionic compound? Generally, it exists into the crystalline solid, which is known as a crystal lattice. Ionic compound do not exist as a single molecule like other gaseous molecule. Like we know that gaseous molecule like H2, N2, O2, Cl2, right? Like that single molecule, they doesn't exist. They are present into the large quantity. Number of NaCl molecule will become together.
Ma'am,
Understand?
why did they mention generally exist? Because are there some exceptions?
Sorry. Yeah,
Why did they mention?
there may be certain exceptions always. Chemistry is
Okay.
not without exception, okay, and hence it is quite difficult as compared to other subjects because in chemistry there are the lot of exceptions. Fine,
Yes, ma'am.
fine. So the melting and boiling point, since ionic compound contain high ionic force, right, or interaction force between the two oppositely charged ions, it require a high energy to break those bonds, and hence it has a high melting point and high boiling points. Right? Ionic compounds
Yes, ma'am.
have high melting point and high boiling points. Apart from that, solubility, these like ionic compound are mostly soluble into polar solvent. Now, what do you mean by the polar solvent? I think I have explained you about yesterday. Polar solvent. Water is a polar solvent. What is the formula of water? H2O. And it gets segregated as a H plus and OH minus, right? So hydrogen has a plus delta charge and OH minus, it's partially negative and hydrogen is a partially positive, right? And whenever such kind of charges get separated into the solvent, such a solvent are called as what? Polar solvent, right?
Yes, ma'am.
HCl also your polar solvent. H2SO4 is also polar solvent, correct? Yes or no? Because
Yes, ma'am.
hydrogen bonds plus Cl minus. Here it will be what? Plus sulfate minus 2, correct? So these all are what? Polar solvent. But then if I take a benzene won't be non-polar because all bond like this I will write. So 1, 2, 3. This is benzene structure, right? Alternate double bond present in that. Each carbon is attached to two different carbon, which is attached to, which has one single bond and one double bond of carbon, right? Same atoms or substituents are there. So each and every atom has the same dipole moment, right? There won't be different dipole moment. And because of that, what? This is non-polar.
Yes, ma'am.
Okay. And what about this? These are polar. Clear? So about the ionic solid, what they why it's been gets dissolved into the polar solvent, because they themselves is polar in nature, because they are formed by positive and negative ions, ionic compound, isn't it? Yeah. Positive and negative ion has a attraction in between. It may result into the formation of ionic bond and ionic compound, correct? So as they
Yes,
themselves
ma'am.
get segregated with the ionic form, positive and negative charge, it get easily attracted toward positive and negative charge present into your solvent and hence dissolve easily, right? But then it does not dissolve into your non-polar solvent. So non-polar solvents are given here, see benzene and CCl4, right? Carbon tetrachloride is also non-polar solvent. Clear?
Yes, ma'am.
Fine. Now next, electrical conductivity. In a solid state, they are poor conductor of electricity, but in molten state or when dissolved in a water, they conduct electricity. Why? Only in a molten state and in when it dissolves into the water, it can
Because
conduct
they split
electricity.
into ions, and
Yes,
ions conduct
movement of
electricity.
ion is very essential, right? Movement of
Yes, ma'am.
ion is very essential while conducting electricity. Because when you take, suppose this is your electrostat
They
and here
move
would be
through
the
the
electrodes connected with the batteries, correct? Isn't it? If you take
Yes, ma'am.
in solid state, ion won't move. But then when it would be in liquid state, positive ion will goes to the cathode, negative ion goes to the anode and get deposited. Isn't it?
Yes, ma'am.
Yes. Yeah. And even in liquid state, same thing would be happen. In molten state and liquid state, it can conduct electricity, but in solid state, it does not. Now, ionic reactions. Ionic compound produce ions in the solution, which gives very fast reaction with oppositely charged ions. Examples are given. See, NaCl in aqueous form, when treated with AgNO3, means silver nitrate in aqueous form, what happened? Which type of reaction it is?
Double
Double displacement,
displacement.
right? Mutually exchange of ions in their aqueous solution to form a two different new compound is double displacement reaction. So sodium will form sodium nitrate. Sodium goes with the nitrate ion, NaNO3, and silver goes with the Cl. It will form the white solid precipitate, right?
Yes.
AgCl. This reaction also you have learned into your grade 10, correct? Yes or no?
Yes, ma'am.
Yeah. So ionic reaction would be happen in an ionic compound only. You might have seen a double displacement mostly. Mostly, I said, there are exceptions. I'll let you know which one. Mostly takes place into ionic compound. Clear?
Yes, ma'am.
99% reactions, double displacement reactions, sorry. 99% double displacement reactions are ionic, right? Yes or no? Only one is
Yes.
there, calcium oxide dissolved into the water. It will convert into what?
Calcium hydroxide plus heat.
Calcium hydroxide, CaOH twice, right? And when this CaOH twice is when, wait a minute. When this calcium hydroxide blow with carbon dioxide, it will convert into calcium carbonate. This reaction is not an ionic reaction, but then to it is double displacement. Correct? This also you have learned might be in last year, right? CaOH twice plus here what? CO2. Carbon dioxide when blow through the which water? Lime water. Correct? You will get what? CaCO3 plus H2O. And this reaction is not ionic reaction. Then to it form a precipitate, though it is double displacement. So that's why I said 99% reactions only, not 100%. Clear? As I said
Yes,
earlier,
ma'am.
there are certain exceptions. Clear? See about the covalent bond, what is given to you. Now see what is given about the covalent bond. Yeah. Covalent bond, Levy's Langmuir concept. See, When the bond is formed between two or more atoms by mutual contribution or sharing of electron is known as a covalent bond. Already I have explained you about it. And in this case, sharing is happen equally. A and B both share the equal number of electrons for the formation of bond. If the combining atom are same, the covalent molecule is known as homoatomic. If they are different, then it is called as heteroatomic. Okay. If A and A combine with each other, it will be what? Homoatomic,
Homoatomic.
right? It will form A2. And when A and B combine with each other to form AB, this will be what? Heteroatomic molecule. Fine. Yes. Now they have given the certain example of the formation of different molecules that we are going to see in detail. Shall I scroll it down?
Yes, ma'am.
Okay. See here, formation of hydrogen molecule has been given to you, right? So as we know that hydrogen, its electronic configuration, atomic number is 1, electronic configuration is 1s1, correct? So hydrogen has only one electron in its outermost shell. And both the electron has been shared by each of the atom to form the hydrogen molecule, right? Hydrogen, one electron from one atom, another electron from another atom. They shared a pair of electron to form a H2 molecule. And you will get the bond hydrogen, hydrogen. Correct? Yes or no? In this case, what happened? See, here is the structure. This hydrogen share one electron, this hydrogen share one electron, and these two electrons would be revolve around this hydrogen as well, and even this hydrogen as well. Because of this, what happened? This H1 and H2 both completed duplet alternatively, means one by one, right? And both
Yes.
become stable like inert gas helium. Correct? It completes duplet in the outermost shell. Okay, and hence this covalent bond is stable. Now next, formation of oxygen molecule, right? What happened in this case? See, oxygen, its atomic number is 8, electronic configuration would be 2, 6, correct? So one oxygen has how many? 1, 2, 3, 4, 5, 6 electrons. Another oxygen has 1, 2, 3, 4, 5, 6 electrons, right? Now what happened? The pair, 2 electron has been shared by each atom of oxygen, right? So how many pairs of electron? 2 pairs of electron has been shared by 2 oxygen atom to form 2 covalent bond, and hence oxygen atom has double bond. Understanding?
Yes, ma'am.
Fine. So here what happened? This oxygen shared its 2 electrons. This oxygen shared its 2 electron, and rest all would be there with them, right? And then here, sorry. Now we just have to complete this circle. Yeah, what you come to know? These 4 electrons and these 4 electrons would be revolve around this oxygen. At the same time, the middle 4 electron again revolve around the another oxygen as well. So if you count the number of electrons around the oxygen would be 1, 2, 3, 4, 5, 6, 7, 8. It completes octet. Then 1, 2, 3, 4, 5, 6, 7, 8. It is also completes octet, right? And hence it is a covalent bond to complete octet.
Yes,
Okay.
ma'am.
And one shared pair form one single bond. There are the 2 shared pair, and hence oxygen has oxygen double bond in its molecule. And remaining 4 electron has been shown like this only. You can check it out this. Clear? These 2 atoms are, these 2 molecules are homoatomic, right? Homoatomic.
Yes,
Why?
ma'am.
Because both the atoms are similar, correct? And now we are going to see the example for heteroatomic. isn't it? You can check. One hydrogen. Hydrogen has 1s1 configuration. Oxygen has 1s2,
1s2,
2s2,
2s2, and 3,
2p.
3p4, 2p4,
Wait a
sorry.
minute. 1s2, 2s2, 2p. How many?
2p4.
Basically, I'll show you in this manner. That would be very easy. Only 6 we have to fill, 2 only. But then I'll show you in this way. You can check. This would be what? 1 electron. Here it will be 6 electron in the outermost shell because inner shell must have the how many? 2 electrons, correct? Because atomic number is 8. Here already we have written. Now what happened? 1 electron has been shared with the oxygen by hydrogen. Another hydrogen also shared 1 electron with the oxygen. And one electron by each, with each hydrogen has been shared by the oxygen. And hence it will form the water molecule. You can check. Now see, hydrogen need a 2 electron. So one from the oxygen, one from itself. So these two electrons would be revolve around the hydrogen. These 2 electrons would be revolve around the hydrogen. And if you see about the oxygen, 1, 2, 3, 4, 5, 6, and 7, 8. Means these all 8 electrons revolve around the oxygen to complete its octet. The hydrogen will complete its duplet and oxygen would complete its octet.
Octet.
Clear? And hence a hydrogen oxygen hydrogen bond has been formed and water molecule would be formed. Clear? Yes?
Yes, ma'am.
Yeah, so it's 4:32. I think our time is up. Tomorrow we'll continue whatever time things are left. Okay. This is the first period for our what? Chemical bonding and molecular structure. Clear?
Yes, ma'am.
Shall I end the class now?
Okay, ma'am. Thank you, ma'am. Bye, ma'am.
Yeah. Interesting. Take care, students. Bye-bye.